Let's start with surface chemistry. In surface chemistry, the first topic we are taking colloidal solution and their types. Colloidal solution. Let's differentiate colloidal solution with suspension and true solution. In suspension, particle size is greater than 10 to the power minus 5 centimeter or 10 to the power 3 Armstrong. In colloidal solution, the particle size is between 10 to the power minus 7 to 10 to the power minus 5 centimeter or 10 Armstrong to 10 to the power 3 Armstrong. In true solution, which are also called crystalloids, the particle size is less than 10 to the power minus 7 centimeter or 10 Armstrong. Second difference, visibility of particles. In suspension, particles are visible with naked eye. In colloidal solution, they are visible only with a microscope. In true solution, particles are not visible even with electron microscope. Separation with filter paper. In suspension, it is possible. In colloidal solution with ordinary filter paper, it's not possible. And in true solution, it's not possible at all. With membranes, in suspension, it is possible to separate the residue and the filtrate. In case of colloidal solution also with membranes or ultrafilters, it is possible to separate. Whereas in case of true solution, the true solution will pass through filter paper. Diffusion. In suspension, particles do not diffuse. In case of colloidal solution, particles diffuse very slowly. And in true solution, particles diffuse rapidly. Settling down. The suspension particles may settle under gravity. Colloidal particles do not settle, but they may settle only under centrifugation. In true solution, particles do not settle at all. Nature. Suspension is heterogeneous, whereas colloidal solution appears to be homogeneous, but actually it is heterogeneous. Colloidal solution is always homogeneous. Tyndall effect, suspension may or may not show Tyndall effect. It depends upon the particle size. Whereas in case of colloidal solution will show Tyndall effect, whereas true solution will not show Tyndall effect. Brownian movement. In case of suspension, Brownian movement is there to some extent in the fresh solution or fresh suspension, whereas in case of colloidal solution, Brownian movement can be easily seen, whereas in true solution, we do not have any Brownian movement. Next, we are taking types of colloidal solution. A colloidal system is made up of two phases. The substance distributed as a colloidal particles is called dispersed phase, or the internal phase, or the discontinuous phase. The second continuous phase in which colloidal particles are dispersed is called dispersion medium. For example, for a colloidal solution of copper in water, copper particles constitute the dispersed phase and water the dispersion medium. Depending on the physical states of the dispersed phase or dispersion medium, colloidal solution are of 8 types. Types of colloidal solution: dispersed phase, dispersion medium, and example. The first type we are taking foam. In foam, gas is dispersed in liquid. Example is whipped cream, shaving cream, soda water. Next we are taking solid foam. Dispersed phase is gas. Dispersion medium is solid. Example is cork, pumice stone, foam rubber. Next type of colloidal solution we are taking is liquid aerosols. Here liquid is dispersed phase and gas is dispersion medium. Examples are fog, mist, clouds. Emulsion. Liquids are dispersed in liquid. Example is milk, hair cream. Next, solid aerosols. Solid is dispersed in gas. Example are dust, soot in air, and smoke. Gel are liquid dispersed in solid. Example is cheese, curd, jellies, food polish. Sol. In sol, solid is dispersed in liquid. Example is ink, colloidal gold. Solid sols, solids are dispersed in solid. Example is ruby glass, that is gold dispersed in glass, alloys, and colored gemstones. A colloidal solution or colloidal dispersion of one gas into another is not possible, since the two gases would give a homogeneous molecular structure. We restrict our study mainly to the colloidal system, which consists of a solid substance dispersed in liquid, and it is called sol. These are frequently referred to as sols or colloidal solution. The colloidal solution in which water acts as a dispersion medium are termed to be hydrosols or aquasols. When the dispersion medium is alcohol or benzene, the sols are referred to as alcosols and benzosols respectively. Next, we are taking lyophilic or hydrophilic and lyophobic sols. Colloidal solution in which dispersed phase has a considerable affinity for the dispersion medium are called lyophilic sols, that is solvent liking or solvent loving. For example, dispersion of gelatin, starch, gum and proteins in water. Colloidal solution in which dispersed phase has no affinity or attraction for the medium or the solvent are called lyophobic colloidal solutions. They are called solvent hating. Now we are going to take up the difference between lyophobic sols or hydrophobic sols and lyophilic sols or hydrophilic sols. How do we prepare? Lyophobic sols can't be prepared easily. Special methods are required, chemical and physical, for their preparation. Whereas lyophilic sols can be easily prepared by shaking or warming the substance with the solvent or dispersion medium. Stability. Lyophobic sols are less stable and they require stabilizer. Lyophilic sols are more stable and can be used as a stabilizer. Reversibility. Lyophobic sols are irreversible in nature, whereas lyophilic sols are reversible in nature. Viscosity. Viscosity of lyophilic sol is nearly same as that of solvent, whereas viscosity of lyophilic sol is much higher than that of the solvent. Surface tension is almost same as that of solvent in case of lyophobic, but in lyophilic surface tension is usually low. Hydration or solvation. Lyophobic sols are least solvated as the particle have less affinity for the solvent, whereas lyophilic sols are maximum solvated or hydrated as the particles have great affinity for solvent. Charge. The particles carry a characteristic charge, either positive or negative. In lyophilic sols, the particles have little charge or no charge at all, and it depends upon pH of solution. Coagulation or precipitation. Lyophobic sols are easily precipitated by low concentration of electrolytes, whereas lyophilic sols are precipitated by high concentration of electrolytes. Tyndall effect. More scattering is shown by lyophobic sols and less scattering is shown by lyophilic sols. Migration in electric field. Lyophobic sols migrate towards anode or cathode as these particles are charged. They are migrating towards oppositely charged electrodes, whereas lyophilic sols may or may not migrate depending upon whether they have charge or not. General examples: most of the inorganic compounds, arsenic sulfides, sol, ferric hydroxide sols are example of lyophobic sols. Lyophilic sols are organic in nature. Gum in water, starch in water, egg albumin in water are example of lyophilic sols. Methods of preparation of colloidal solution. The first method, lyophilic sols may be prepared by simply warming the solid with liquid dispersion medium. For example, starch with water. On the other hand, lyophobic sols have to be prepared by special method. These methods fall into two categories. The first category is dispersion methods, in which larger macro-sized particles, that is large size particles, are broken down into colloidal size. Second is condensation method, in which colloidal sized particles are built up by aggregating single atoms, ions or molecules. This method is known as condensation method. Next we are taking electro-dispersion. This method is called Bredig's arc method. This method is suitable for preparation of colloidal solutions of metals like gold, silver, platinum, etc. An electric arc is struck between the metal electrodes under the surface of water containing some stabilizing agent such as trace of KOH. The water is cooled by immersing the container in the ice bath. The intense heat of the arc vaporizes some of the metal which condenses under cold water, forming colloidal solution. This is the diagram for Bredig's arc method. Two metal rods are taken as electrodes and water and KOH solution has been taken. Now very high voltage is passed through these electrodes. This electric arc generates lot of heat. This heat helps in vaporization of metal. So vapors of metals are cooled with the help of ice or ice cold water and we get colloidal solution.